Okay, so let's look at another word problem. This one is a bit longer, but it's going to be the same idea. Now, okay, so over here we have Teresa has a circular pool of 30 feet. That's 30 feet long. 15, sorry, Teresa has a rectangular pool that is 30 feet long, 15 feet wide, and 40 feet deep. Teresa, she fills up her pool using city water at a rate of $3.95 per 100 gallons of water. Nancy has a circular pool with a diameter of 24 feet and a depth of 4 feet. She fills her pool with the delivery service at a rate of $200 per 6,000 gallons. If Teresa and Nancy both fill their pools 6 inches from the top of the pool, determine and state who had more to fill her pool. Okay, so from here we just want to go ahead and just underline our important information. So Teresa over here, she has a rectangular pool with these dimensions. And she fills up her pool using city water at a rate of this. And then we have Nancy, who has a circular pool with a diameter of 24 feet and a depth of 4 feet. And she fills her water with the service with this price. Now, here's the question. If they both fill their pools 6 inches from the top of the pool, determine and state who paid for more. And this is a thing they gave us for gallons. Okay, so all right, so we have two things we're comparing. We have a rectangular pool, and now if you haven't seen a pool, a rectangular pool usually looks like a rectangular prism. So it's going to look similar to this, right? And it's going to be 30 feet long, 15 feet wide. So this is the width, that's the length. And then it's going to be 4 feet deep. So that's going to be your height. How deep it is at your height. Now we have, and this one is $3.99 per 100. $3.95. Okay, so now we have a circular pool that is, oh, this is T, this is N. If we're doing a circular pool, this one's going to be close to a cylinder. Okay, so this one is going to have a depth of 4 feet, and then it has a diameter of 24 feet. Okay, so, and this is $200 per 6,000 gallons. So just by looking at it, it seems like Nancy's paying a lot for her water, or maybe it isn't. I don't know. Or maybe Teresa is. So we can't really tell much from here other than we have a rectangular prism for Teresa, and we have a cylinder for Nancy. Okay, so what's important here is that they fill their tanks 6 inches from the top, right? So what they mean is 6 inches to the top. I'll just tell you this one. So they have 4 feet, right? If their depth is 4 feet, the actual one for the water, we're actually going to use hold on a sec. 8 minus 6. Okay. So the actual height is going to be 3.5 feet. Okay. the way I did this is I changed 4 feet into 48 inches. And then since everything's already in feet, I changed into 48 inches. And they only filled up 6 inches from the top. That means I'm taking away 6 inches. And this is going to give me 42 inches. And I need to change this one back into feet. So I do 42 divided by 12, which is 3.5. Now, luckily for me, I just had to do all this calculation for one of them because they're both 40 feet, 4 feet tall. So this one as well, the real height we're going to be using is 3.5 feet. So we're not going to use 4 feet here. We had to change it because they filled their pool 6 inches from the top. We're going to change it to 3.5. Okay, so that's finished. Well, not finished. Now we need to go ahead and find the volume of it. We're finding the volume because we want to know how many total gallons of water was used to fill up this pool. And the way we can find that out is by using the volume. Okay, so we have Teresa. It's a rectangular prism. So we're going to do length times width times height. So the length is 30 times width is 15 times height is 3.5. If you multiply all these out, you're going to get this for your volume. Now we have Nancy, and we've seen before that the volume is pi radius squared times height, pi half. So the diameter is 24. The radius is going to be half of 24, which is 12 feet. Radius is 12 squared times 3.5. And if we put this into our calculator, let's round it to the nearest tenth, just because it's easier to work with. This is 83.4. So that's our volume. Now, it seems as though between the two, Nancy is the one with Nancy's pool holds the most water. So just by looking at this, I'm going to guess maybe Nancy's the one paying the most. But let's change them all into gallons. So it's saying so this notation is telling us each of those 100 and 1,575 feet is going to give you 7.48 gallons. So this shows that we need to multiply this by 7.48. Okay, and if we multiply all of this by 7.48, we're going to get this as gallons. So I just changed the cubic feet into gallons because that's how they're measuring the price of their water. Okay, the same thing over here. This is saying for each cubic feet, each of these is going to have 7.48 gallons. So it's the same idea. We're going to multiply and you're going to get 11843. Let's round this to nearest tenth again. Yeah. Okay, so this is how much their pools hold in gallons. Now we need to use the prices from before to show us who paid the most. So let's see. Teresa paid, okay, so this is based on per 100. So what I'm going to do over here is that I'm going to take this and I'm going to divide it by 100. I just want to see how many hundreds make up this gallon. And if I do that, I'm going to wind up with 117 gallons and 81. There's that many. And then over here, I'm going to divide this one for Nancy. This is Teresa, this is Nancy, by, let's see, what was it, 6,000? Yes, 6,000 gallons. So let's divide this one by 6,000 gallons. 843.8 divided by 6,000. And so that's just about like 1.97. Okay, and now we have the amounts of gallons in each, and I have to multiply Nancy's by $200 because each of these she's paying $200. And I'm going to multiply Teresa's by $3.95. So then over here, 200 times 1.97, that's $3.94. And then over here, 17.81 times 3.95. Oh, sorry. Wait, I forgot the decimal. That's 465.35 cents. Okay, so between these two, who paid the least? It's Nancy. Nancy, she paid the least. All right. Okay, so this is just one example of a much longer problem, but here we're comparing the rectangular prism with the cylinder. Right? And we found that even though Nancy, she's using a special water service and she has a pool that holds more water, she's actually getting a better deal because her water service is actually pretty cheap.